Hi there, my name's Glenn and welcome to All About Arduino. Today I'm going to look at the serial device on Arduino and how we can use it to help debug our programs, how we can use it to control our Arduino, and particularly look at remote control for a project that might be deployed. And finally I'll look at a two-player game where we look at how serial communications can be used to coordinate activity between two separate Arduinos in a two-player game. Okay, so let's get into it. But if you do find this video interesting, then please leave me a comment. Don't forget to like the video and subscribe to my channel so you get future notifications. And look for me on social media. The links will be in the description below. Okay, so let's get stuck into it. Normally I'd give a little bit of a presentation about what we're going to cover. Feel it like they're probably getting long, but so I'll just give a brief one this time. And that's pretty much it. So we're going to explore the serial objects, including feedback, so printing from the Arduino, control, so reading stuff into the Arduino, some techniques and some attributes of the serial object, and some interaction between devices. So I'll look at a few projects starting with something very simple and then gradually work our way up to something like this, which features two megas that will be interacting. So I just set one. So you already can see there's interaction because resetting one of them could cause the other to reset as well. So what it's done is it's displayed a tic-tac-toe or a noughts and crosses grid, and we can play the game. So communications is across these two wires, and these are connected to serial 1 on the Mega, and so we'll look at that in a bit more detail. But basically, we can click on the screen and our move will appear on the other side. So this one says I am noughts, and so I'm waiting for the opponent to play. And this one says I am X's or crosses, and it's our turn. So I'll click here, and we should see the play appear there. So now it's our turn on this side, so we'll click that, and again the play is reflected there. So you can just keep going like that. And then when one wins, obviously it marks that. So green is the winner and red is the loser. And then once we've finished playing, ready to reset, either player can click the reset little button there, and then it resets and it's ready to go again. So I was going to show you the development of that entire project, but I felt that's getting a bit long for this video. But if you want to see that, then leave a comment and maybe we can do that separately. Okay, so I'll start with this simple program. I'll use this Uno, which has got these LEDs attached, which I won't be using just yet, but we'll be using them shortly when we sort of start sending some commands to it. And you've probably seen this before. It's fairly standard in most programs. There'll be a serial and then begin, then some number. A lot of them will use 9600, and I'll come back and visit that in shortly. And you've also probably seen this, which just prints a message. So if I upload that, I just bigger that, load it, we'll save it. So all about Arduino, a new project folder, so serial. Okay, and so it's uploaded. Nothing much happens on Arduino. That's because it's not really doing much. But the key here is the serial monitor. So if I open that, then hopefully we'd see some messages here, but we don't. And the reason for that is because this number here. So see here I've used 9600, but here it's 115,200. So the problem is that this doesn't match up, and it won't work unless these match up. Now this is a throwback from the olden days when a serial was actually a primary communication between terminals and computers in a large computer room, and you needed to sort of specify the speed that the data is being transmitted. So if it doesn't match up, it doesn't work properly because of the mismatch. It's not so critical in a USB environment because it's not affecting the speed of the USB, but it is important for the way it sort of generates the data. So if I set this to 9600, and there it is, it's just worked. Now I tend to like using the higher speed, whatever that number was, 115,200, just because it sort of updates this much more quickly. So the speed is honoured, it's just not really that critical in our modern times. So let's just do a little something else. So in here, I'll get it to output some messages of a counter. Okay, Okay, so we output a little label count, then the actual value of our counter, we increment it, and then we pause for a bit. So I just upload that. Now, I don't know if you've seen this notation before, static int count. Basically, that means that I want it to kind of be a global variable, but private to this function. So I can't use this count anywhere else, or if I did use it, it would be a different count. But I want to basically retain it across calls to the loop. If I didn't have that static in there, then it'll always be resetting to 0. If I go back over here, we can see the count has already started in. Okay, so that's printing. Obviously, there's a few different things we can print, but that's basically the outputting. So let's move on from here and let's accept input from the console. So you'll notice that there's this little button or this little box up here, and we can type stuff into it and hit send, but nothing much happens with that. If you look closely, you might see the LED, an extra LED sort of light up. I'll make it a bit bigger. Hit send. Look closely, we might see this RX one that's next to TX blink briefly. Okay, 1, 2, 3, send. So you saw it. So it's actually sending that data to the Arduino, but in our code, we're not doing anything with it. So let's fix that. All right, so this bit can remain the same. I think I'll just comment that out because that delay is not going to help us at all. In fact, it'll mess things up. And what I'm going to do is do an if. And that if is doing as it implies. If there is something available, meaning something has been sent from the PC or somewhere, if something is available, then I want to do something with it. And what I'm going to do is I'm going to read it. And so what I can do is I can then just print that. And so let's upload that and see what that does. What we should see is anything that we type will appear in the serial monitor. I'll put here, might do it, position these while that's uploading. Okay, so we've got that test serial message, and this time I'll type in hello again. And look at that, it's echoed it back. There's also some command recall here, so if I hit up arrow, it'll scroll through previous messages. That's kind of a nice feature. And if you're using the IDE 2.0, or whatever version the 2 is, this sort of works the same way. It's just the placement is a bit different. And also the speed is sort of positioned in the top right-hand corner of the window rather than the bottom, but it still has to match up. Okay, let's see if we can't do something else with this. Let's do some operations on it. So what I'm going to do is I'm going to say if is lower, so is this a lowercase character? Then I'm going to say ch equals to upper ch. Else, if is upper ch. So what this is doing is it's looking at the character and checking to see if it's a lowercase character. That's what this line does. And if it is, then it just changes it to an uppercase character. Otherwise, if it's an uppercase character, it'll convert it to a lowercase character. And if it's neither upper or lowercase, it won't do anything to it, so it'll just print it. So what we should see is if I type any lowercase letters I type in should be printed back as uppercase, and any uppercase characters will come back as lowercase, and anything else will remain unaffected. So just upload that. And so we'll give it a mix of characters. So I just make it a simple pattern. So a capital A, capital B, little b, capital C, little c, and then a 1, 2, 3. I'll throw in some symbols too. So what we should see is the capital A become a lowercase a, and the lowercase a become a capital A, and so on. And there we have it. So what that means is that these characters are actually something that we can do something with. So indeed what I'll do is I'll modify this program so it shows us a bit more information about the character. I'll comment this out. So we're still reading the character up here and putting it in the ch variable. So I'll continue to use that. and I'll print out some sort of diagnostic information about it. So I'll start with some quotes. I'm apparent why that's important shortly. Okay, so what have we got now? So what I'm going to do is I'm going to print a quote, then the actual character, and then a closing quote. So where we've got this A here, it'll put the A in quotes. Then it'll print equals 0x, and then I'm just going to print the character again. But before I print it, it's going to do this. It's going to cast it as an integer. So it's going to take the character and cast it as an integer. So it'll be the integer representation of A or B or 1 or exclamation mark. And it'll print it out in hexadecimal. Could omit that and it'll print it in decimal, but you can sort of see a bit of a pattern if you leave that in there. So I'll upload that. All right, so let's bring back that character string just now. Also, I'm going to turn this one to nothing. No line ending, just briefly. So I'll hit enter here. And again, it'll send that information out for us, and we can see the values that it's sent up. So there's the output I explained. So we get the character in quotes, then it equals, and then it's the hexadecimal value of it. So this is 41. So maybe you know the secret, maybe you don't, but that's a bit odd if you don't know the secret. And the lowercase a is 61 hexadecimal. The B is 42, so that's one after the A. The little b is 62, one after the little a. So these numbers are all representations of these characters. Similarly, the digits 1, 2, and 3 are 0x, 31, 32, and 33. So they're not actually a 1 or a 2 or a 3, and this will become important when we get to the next example. And then some of the symbols, so exclamation, and they're a bit more random because they're sort of not just the way they are. So where are these numbers coming from? Well, we look at something called the ASCII chart. We can see some correlation there. So get both of these to show. Yeah, there we go. So ASCII stands for American Standard Code for Information Interchange. So it's a way of saying, of giving a value or a number to each letter, because computers don't really understand letters, they only understand numbers, and how you interpret the number can mean, or give meaning to that number. So this 41 could be the temperature, for example, but if we use it as a context, different context to interpret as a character, then it could mean an A. It would be an altitude. So it can mean anything we like. It depends on the context. So in the case of the serial of the print of a character data type, it's interpreted as a letter. So if we look at this second column here, we have hex. So there's our hexadecimal values, and then the symbol. These are special characters, which we'll look at later on, particularly this CR, and LF, it's BS, which means backspace, line feed, and carriage return. If we skip past those and get into the displayable characters, then we see here we've got our our one digit, and that's 31. Where's that gone? There it is. So check. 2 is 32, 3 is 33 hex. We go a bit further, find our letters. So capital A is 41. That there, check. Capital B, 42. Check. Capital C, 43. So yeah, check. And then the same for the little letters. Lowercase a is 61. So that one, check, and so on. Now, I turned this off. So what I'm going to do is put new line. And I'll just type in one character. Let's use a capital A, and I'll press that. So notice we've got the capital A, 41 as before, and then it's kind of split the quotes over two lines. So that's the new line character. It's also given us the code 0A. So if we go back up here to these control characters and look for 0A, then we can see that's a line feed. And that's what that means. It in the olden days of typewriters, there was two characters you need to send. One was a carriage return. So if you can visualize a typewriter, that's when the platen sort of moves from wherever it is back to the left-hand side. So you're typing in column 1 again. And then separately, there's a line feed character which rotates the platen. So it moves the paper up to another line. So this is what this line feed is doing. It's moving up to another line. If I change this to carriage return, this time I type in a B, just to sort of allow us to see the different output. So we can see the B, and that's 42 as we'd expect. And this time it's printed basically the two quotes together, and 0xD, carriage return. So that's the one that would move the platen or head back to the left-hand side, ready for column 1 printing. Now it seems like the serial monitor here ignores D because it's just not doing anything with it, but it could do something. And if we look at another program later, we might actually see that. I could also send it to both new line and carriage return because some programs require both, particularly if you're sort of working with Bluetooth devices. They seem to want to have both. Again, we'll look at that a bit later. If I set it to this, then what we should see is we should see our character with a 0A and a 0D. Well, this time I'll use C. And there they are. So there's our C. It sends the carriage return first. So that would move our head back to position 1. Then the line feed, so we advance to the next line. And that's what's happening up here when we do the print line. It's outputting one of these line feeds, maybe a carriage return as well, I'm not sure, but it's certainly outputting a line feed, and that's how we get how the serial monitor knows to put a new line in. Okay, so because our characters are in fact just numbers, we can actually do our own stuff with them. So let's comment this part out. So we'll keep our printing of the character we've received in quotes. And what we'll do is we'll just step it to the next character if it's a printing character. So if character greater than equal to, and I'm going to use a space. So why a space? Well, because if we look at these, all of these non-printing characters, special characters we don't want to do anything with, but space is the first one of all of the printable characters. Space is the last one. So if we get anything that's greater than or equal to a space, we want to do something else with it. So for example, if we got an A, that's greater than or equal to a space, so we would do something with it. What do we want to do? So I'll just print a transformation symbol to find a new character, and we'll add 1 to it. So just an ordinary add 1 expression. Now I won't bother with quotes this time because it's definitely going to be another printing character. We'll just print it out. So I'll upload that. So what's happening here is we'll receive the character. If there's 1, we'll output it in quotes as we did before. And then we'll put this sort of conversion symbol, and then we're going to add 1 to it, and then we'll print it out. We could also subtract 1 as well. So you could perhaps explore with that, maybe add 2 to it, so on. So anyway, there's our serial. So what I'll do is I'll type in A, B, C, all in capitals, and 1, 2, 3. And as you can see, we've incremented it. So our A has become a B, our B has become a C, our C has become a D, our 1 has become a 2 has become a 3 has become a 4, and we didn't do anything with the line feed. So, because we're doing both. So I'll just make that 9, or yeah, we just get the new line. So A, B, C, D. So that's what we get out. Okay, so let's move on and let's see if we can use some of our new gained knowledge and control things. So what I'm going to do is set up this simple little circuit here. And in fact, you can see it over here. I've had to put the pink thing underneath so you can actually see the servo arm, which will make move. Otherwise, it was very hard to see it in the black background. So hopefully that's okay. And as you can see, it's fairly straightforward. We've connected the power and the ground to the servo, and then the actual servo is connected to pin number 9. And what we'll do is we'll send it the characters as done earlier, but this time instead of converting them or whatever, we'll use the information to servo. A 0 will put it to the 0 degree position, 9 to 180 degrees, and as it says there, the intermediate values will be partway around the circle in increments of 20 degrees. Then we'll add a C to send to the servo and an S to sweep the servo. Okay, so let's get started with that. We'll start a new program, and from now on, I'm going to use the faster speed because that's just what I normally use, and it's just a habit that I use. Plus, if you're doing a lot of output, much better throughput, so we'll use that. If you want to continue using 9600, that's fine. You just need to be consistent throughout all of your programs and the serial monitor, that's all. I'll print up a little label describing what the program does. Copy and paste some of this over here. Close that brace. What we'll do is, once we've received a character, we'll figure out what it is. So I'll put the entire process in here, and I'll add functions to support it as so. So the first thing I'm going to do is check to see if it's between 0 and 9. Okay, and if it is, then we'll do something about positioning the servo. So this will be the center, and that could be upper or lowercase, and as we've already seen, they're different codes, so we need to compare for both. And so if it's a C or a C, then we'll do something with that. And the same for sweeping. Let's do the positioning first. What I'll do is I'll calculate a percentage. And so what we said would be 0 is 0 and 9 is 180 degrees. So I'll just put that in a comment just to make it a little bit easier to remember later on. I'll distinguish these as characters as opposed to numbers. The first thing we need to do is convert the character we've received between 0 and 9 to a number. So the way we can do that without knowing what code the 0 is, hex 31, but without having to remember that, we can actually do something like that. So this will give us an integer, 0 to 9. And so to work out the percentage of our rotation, we just need to divide it by 9. So that'll give us 0 for 0, 0.1 for 1, 0.2 for 2, and 1.0 for 9, or 100%. And then the next one I'll do is I'll call a function. Okay, so that's great, but we need to have a function that does that. So void. I've got our function here. So we'll convert our percentage of rotation from 0 to 180 degrees into an actual position in degrees. Right, so percentage was 0, 0.1, 0.2, 0.3. And so if I multiply that fraction by our full scale of rotation of 180, then I'll get an actual degree value. So we'll print that out. The last thing I'll do is send that to our servo, which I haven't created yet. I recognize that. So define our servo pin. I think it was number 9. Include the servo library. It might be a good idea to have a little usage function here as well. Print some helpful information. Let's copy and paste that. Okay, so let's upload that and see what happens. Now this is a different Arduino, so it'll be on a different port. Still an Arduino, load that, save it. And looks like we have a problem. Oh, we didn't create a servo. Okay, so I already heard the servo move, but let's open a monitor. Now, you can see here this time we have some sort of strange characters. That's because our baud rate doesn't match up. So here I've used in 115200, but the monitor is still set for 9600 from our previous example. In the case of the slower speed, sort of interpreting the data incorrectly, so we get gibberish as opposed to previously where it was so fast it was confused about what we were getting. I need to match up the speeds again. And there's our prompt. So if I type in a letter, a number, so let's say I'll put 5, so that'll move us to the about 5/9 position, so not quite the 50%, about 55, 56%, something like that. And so it's moved it to there. If I type in 1, that'll take us back there. 0, it would be a little further. Hopefully you can see the horn moving. If I do 9, then it moves to the opposite position. Or if I type in other letters like C, nothing happens because we're not doing anything with that yet. Well, an S for sweep. So that's nothing. Okay. What I might do is also put the else in here since I've created that usage function. So if we get any other character, then I'll print that out. So let's do the center. In this case, it's actually pretty simple because all I want to do is position it at 0.5. So this is actually a kind of nice feature, this servo, to sort of start modularizing the code. So we have this little function that we can use in different ways. So let's upload that and see what happens. So we haven't, oh, wrong punctuation character, full colon instead of semicolon. And there's our usage information prompt. Now, because the line ending is at new line, and we already saw that was a line feed control character, that's not going to be a 0 to 9, not going to be a C, and it's definitely not going to be an S. So we should get this usage information incorrectly, but let's see what happens. So I'll position the servo at 0 first, sure enough, and there we've got a helpful message. What I'll do is I'll make it no line ending, so we're not getting that carriage return and line feed being sent through. And then I'll try using C for center. And sure enough, I go to 9 and then try an uppercase C, it'll also center, and you'll note that we're no longer getting that helpful message. If I put an invalid character in, like, well, S will be okay because that's something that we're looking for, even though we're not doing anything with it yet. But if I put in something like an H or an asterisk or something, then that's none of the valid characters, so we'll get this error message. So it's always a good idea to have something like that if you're going to create an interactive program like this where you can send commands to it, sort of if you're typing stuff in and nothing's happening, you sort of don't know why not or can't remember. So if you just print a helpful little message like that, then that just explains what's going on. Let's just do this last one and then we'll move on to something else. So to keep the main loop simple, what I'll do is actually create another function called sweep, even though I'm only ever going to use one scenario, and that's that one. And I'll put all the logic in there for this. So what I'm going to do is I'm going to track or remember the servo's current position and then basically move it to one extreme, then all the way through 180 degrees to the other extreme, and then back to its original. So to remember it, we just read it, and then we use that later on at the very end to reset the servo's position. And in fact, it'll kind of default there because I'll use this to control where we end up. So next thing I'm going to do is I'm going to have a working position, and I'll use that, I'll initialize that to current setting, and then we'll just use this pos to work our way forwards and backwards. So what I'll do is I'll move it up to the 180 degree position. So while the position is less than or equal to 180 degrees, I basically write that position. So that's not actually going to do anything the first time around. And then I'll increment it by 1, and I'll have a short delay. I think 15 is a good time, just to allow it to physically move before we send it the next one. And so when it gets to 180 degrees, we'll just do this again. So I'll just repeat this while it's greater than or equal to 0. This time we'll decrement it. So we increment from where we are to 180. Then when we get to 180, we decrement from 180 all the way down to 0. Finally, we'll go back towards the 180 degree mark, but instead of going all the way to 180, we'll stop. We'll get here. So while the position is less than or equal to the original position, basically that. I think I'll also put in a print message. And we'll upload that. Hopefully that will be fine and ready to go. That looks promising. Okay, so we should be able to do an H for help. Yep. And put it to the 7 position. Center. It's not moving. Oh, there we go. And then lastly, the sweep. So if I position the center, sweep. Nice. Now I can also enter multiple commands. Now I probably won't see anything this because it'll process them too quickly. But if I position to 20% and then center it, you'll see the messages come up. But because there's no delay between the sending of the characters, there's no time for the servo to move. But we are centered right now. So if with those commands, it should recognize that the servo is at the 20% mark. So it'll store back to there after we do the sweep. So I'll do S. So let's see what happens. Okay, so I was wrong. It did actually have the time to move. So if I try that again, 6 and S. Nice. Okay. That's a simple example of how we can use data sent from the serial monitor to control something. Okay, so we'll switch gears back to the LED project, and rather than using single letter commands like the servo one did, we'll use double letter commands to different things. So here's the circuit. It's pretty straightforward. Basically, there's a bunch of LEDs, 8 of them, connected from pin 2 to 9. Obviously, there's a current limiting resistor, and then we go to ground. And so the circuit's pretty straightforward, just lots of it, that's all. And so the 2-character command is going to be a letter, which identifies the GPIO pin. So A would be pin 2, B would be pin 3, C would be pin 4, and so on. And then a 0 or 1 will set the GPIO setting. So if I said A1, then that would turn this first LED on. A is port 2, and 1 would be high. If I said B, that would be port 3, which is grey wire goes to this white one, so it would turn the white one on. I think I tried to line the colours up on my breadboard with that diagram there, so it'll be sort of similar to that, but the colours don't really matter that much. Okay, so let's get started with that, shall we? I don't think we need this one anymore. This one here for now. Save that. Okay, so we'll just go back here and recover the servo one, and we'll borrow some stuff from it rather than rekeying it. So there's a banner, a serial setup, call the usage. We'll set up a boilerplate for the usage. There's a label. Okay, so that's our usage information. Once again, we will want to check if there's something to do. And now this time, because we had sort of 2-letter commands, we need to sort of track which LED we're talking about and what operation we do, because as you would have seen here, it was one character was coming in at a time. So we can't sort of really get 2 characters at once. You sort of can, but also it doesn't really work that way. They come in one at a time. You can collect them up into chunks of 2 or more, and we'll look at that a bit later. But literally they're coming in one at a time. And so we need to deal with that situation. So what I'm going to do is put it into a function called process command, and we'll work on that. Okay, so now we don't need it anymore. We'll start off simple and test our turning things on. I'm going to use a fixed pin number 2, and I'm going to say if character equals to 0, then I'm going to do digital write low. Okay, so we'll give that a go and see what happens. And spoiler alert, not much. Yeah, so spoiler alert, it's not going to work. Think of why. Oh, one of the reasons our pin mode. Just set that up as well. That's not the reason though. Okay, so set the pin output. So we'll just give it a try. We've got our usage message working. Well, so we can confirm that that's working. Be good to go. Okay, so if I type in a 1, I should see pin number 2 set to a high. So 1, and of course nothing's happened. 0, nothing happens. We can see we're getting the 1 and the 0. I can do A, but still nothing happens. And so remember back to a first program, back over here, we printed these things out as hexadecimal. We're not actually getting a 1 or a 0. We're getting a 30 hexadecimal and a 31 hexadecimal. And that's not a 30 or 31 hexadecimal. It is, in fact, a character 0. So hopefully you remembered that, but I did that deliberately to remind you that even though we're typing numbers in up here, they're not actually numbers, they are characters. You don't get a number through the serial monitor. Again, there's support where you can get numbers out of it. Look at that a bit later. Well, actually, we won't look at that later because it's problematic, but it's just a reminder if that's how it works. Okay, so this time, if I type in the 1, you should see pin number 2 light up, and it didn't. Okay, silly me, I had the LED in back to front because of something else I was doing and I didn't put them back in properly. But now it's working. So if a 0 or a 1, I'll get that working. And just to prove my previous point, so just to prove my previous point, we change those back. Now it does not work anymore. 1, nothing happens. 0, nothing happens. I can type anything. Nothing happens. So no, they all don't work because saying we don't get numbers out of the serial read, we get characters, and character we're getting is a 30 hexadecimal or 31, and that from this program. Okay, so now let's set it up so we can address the LED. So the way I'm going to do that, first of all, I'm going to make a copy of this and comment out the old one, otherwise it'll be confusing for our compiler. And instead of setting the pin number equal to 2, in fact, I might just initialize the 2 just so we have some initial value. I'll print out the character, and as before, I'll keep this. What I'm going to do is I'm going to add in some logic here to check for the characters. And so the first thing I'm going to do is I'm going to say is convert it to uppercase. So if it's a lowercase character, just convert it to uppercase. That'll make the if here a little bit simpler. So then I'm going to say if character greater than or equal to A and character is less than or equal to, what was our range again? H. Then I'm going to change the pin number to A for 2. So effectively what I'm going to do is calculate the offset of our character. So that will be character minus the capital A. So if it's A, that'll become 0. But we don't want it to be 0. We want it to be further offset by 2. So we'd make it 2. So therefore B minus A would be 1. So 1 plus 2 would be 3. And C minus A would be 2. So 2 plus 2 is 4, and so on. So that sets our pin number. And remember from earlier, static meant that it's going to remember what the pin number was the last time we called it. So it'll set this to the correct pin number, hopefully. And then it will do this. So that should be all that we need to do. So let's upload it and see what happens. Okay, so to simulate what happened before, I should be able to type in A1, and lo and behold, it comes on. Be able to do B1. In fact, I should be able to do a bunch of them. C1, D1, and maybe turn off B0. And lo and behold, we've got the first 4 being on, off, on, on. Yeah, so it worked. Amazing. Okay, so I'm going to just comment out this. Don't really need it. But just make it works. A, that order, A1. There we go. All right, so it's still working. Now the reason I'm going to introduce that is because I want to show you some other tools that are quite handy. I'm going to start with PuTTY. That's column 20, 1152. So if you're not familiar with PuTTY, it's a terminal emulator. And we can usually use it for accessing Linux systems or other sort of character mode type systems, such as a Raspberry Pi over a local area network. But it also has the ability to interact with COM ports. There's a whole bunch of programs that do this. TerraTerm, I think FreeTerm's another one. There's a whole bunch of them that do this. I have Putty. I like Putty. I know Putty, so I'm going to use Putty. If you don't like using Putty, that's fine. Now, the first thing I'm going to do is I've selected this one that I've previously called Arduino Serial. It's set to COM20, which is where our Arduino is connected. It's got the right speed, and we use serial port, so that's all good. So I try and open it, and it's going to fail. Now, this is a common problem that we see in the forum on Reddit. Access is denied. It's usually reported here in the compiler at this upload phase where it's trying to upload the code to the Arduino. And the reason that we're getting this access is denied is because something else is holding the port open. And in this case, that something else is the serial monitor. So I'll just click OK on there and get rid of it. And we'll start it again. So again, I'm going to load this up, but this time I'm going to close that. So there we have it closed. I'll open this one. Bit of luck, we see our error message, sorry, our helpful message. And so I can type in things like A1, B0, C1, D1, which I've already got. So A0, B0, C0, D0. And now they're all off. So it's definitely receiving the commands and it's definitely working, but it's a little bit hard to see what's going on here. So I'll put this over to the side here, and can you guess what's going to happen when I try and upload this? But what I want to do is I want to make it so as the characters I'm typing are typed and received, I want them to echo back to Putty so that I can see what I've been typing rather than this sort of blank screen. I'll put this over here, and the way I do that is I simply echo it back. Echo back the character that I've received. And then it should appear in the Putty, just like these other messages, like LED control and this information up here. Okay, so did you figure out what's going to happen? I already gave you the answer. And there it is, can't open device COM20 because something else is holding on to it. Now, it could actually be a permissions thing, like you're not allowed to for some reason. That's sort of unusual on Windows. It happens more on Linux, and of course you get a different port name. But again, it's because it's opening it. What I'm going to do is I'm going to do new session, just leave it there like that. Yes, I want to close that. That's sitting there. I'll load it up because it hasn't opened it yet. It's just loaded it up. And then I'll try the upload again, and this time it should work just fine. And there's loaded up. And now I can open this and get the message. There it is. Now this time with a bit of luck, I should be able to see what I'm typing in. So A1. Notice it's lit the LED up immediately. B1. C1. A0. B0, and I don't know why I'm saying it because you can actually see what I'm typing this time. 1, F1. So now we can see what's going on, and we can see that those characters are being sent to the Arduino for processing. Now, importantly here, it is highlighting it's being sent all in one go. Now, the difference for the serial monitor is it's still being sent all in one go, but what's happening is that serial monitor is accumulating all of the input, and when you click send, it sends all of it in one, effectively one block, just rapidly, one after the other, sort of typing as fast as you possibly can. So why do we want to use Putty? Because obviously it's a bit of a pain that we can't sort of upload things and have the Putty session open. The Arduino IDE is sort of smart enough that if you have the serial monitor open, you'll see it kind of grays the serial monitor out, and it works correctly in that scenario. I think if I open the serial monitor, I'll probably get the same error. Yeah, so port busy. It's saying that the access is denied, but this time it says port busy. So if I close this, I'll just hope that there, just in case I want to use it again. If I close this, open the serial monitor, and try the upload, you'll notice that it goes grey. Right, you can see it's sort of gone grey, and then when the upload is finished, it'll sort of lighten up again. That's because the IDE is smart enough to talk to its serial monitor and says, hey, they've uploaded, or they've requested an upload, so you need to sort of release the serial port so I can do the upload, and then I'll let you know when the upload is finished, and so then you can turn back on again, sort of thing. So that works for the Arduino IDE because it can coordinate with itself, but PuTTY is a separate program. So why would we want to use PuTTY? Well, sometimes if you have a project that's sort of out in the field or you've left it running, it might not be convenient to upload the Arduino IDE so you can just get this serial monitor. You might want to have some other way of talking to it. And also, when we look at like the Noughts and Crosses game, we're actually using a different serial port. So I'll use PuTTY to send or simulate being the other system, the other player, and then we'll use the serial monitor and the upload path to upload new versions of the code if we needed to, independently of the serial monitor. And it's much less confusing because we know that our PuTTY session is going to be simulating the other terminal or the other device. So that's PuTTY, but there might be some other reasons that you want to do this. So I'm going to load up another little program called processing. Now this is a nice little program. I haven't used it very much, but I've created a simple little program that I can control the D. Now I'm going to have the same problem here. If I don't close this, it's going to have the same problem, because what it does is it tries to open up the COM port that our Arduino is connected to, and we'll use this to actually control one of the LEDs. I'm going to have to close this guy again. Now I won't sort of go through this in detail, but basically what it's doing is it opens up a little window, then it connects, it lists out what COM devices it sees. So that will be this one. That'll be this list. Well, it probably won't say 15, it'll say COM20 and COM30, because I don't think 15 exists anymore. So it'll list COM20 and 15. Hopefully it won't say that, because it then connects to the first one, and it'll use that speed. So it connects to the serial port, and then it sets up a little reader to print any, allow me to see any messages that come back from it. And then it keeps calling this function. And so what happens if the mouse is pressed, then it will send an A1 to the Arduino if the left button is pressed. It also gives some feedback on a screen. If the right button is pressed, it'll send an A0. Otherwise, it just sends like an empty circle. So we should be able to see me pressing the button and also the reaction on the Arduino. So I'll just run that. Okay, so it does get COM50. That's unfortunate, but we can handle that by saying I want to connect to the first one as opposed to the 0th one. Try again. Okay, it's worked this time. So what we're seeing here is the hollow circle, which is basically the no button pressed in the window, and we can also see our message come up here. So if I left click on here, it goes green, and you can see the LED has come on. And if I right click on here, get a different color circle and it goes off. Left, right, left, right, left, right, left, right, and so on. We're going to have some fun with that. But the idea here is that we're not limited to doing stuff with the serial monitor. We can actually have other fancy programs that draw a nice green circle, or like Putty, where we can just type commands directly rather like we do in the serial monitor to send data to our Arduino for control. Now I'll do one more little example, but first I need to get a little Bluetooth module. So this is a simple Bluetooth module. And what I'm going to do is, I think I'll put it in here. Put it in here. It's off the camera, but I've bridged the power rails at this end of the breadboard. So I've got the ground and the +5 coming in there. In fact, I'll adopt my policy of turning the power off. Make sure I connect it up correctly. So C is this one. So that to 5 volt. The wire for the ground. Black wire for ground. I use these purple and grey wires for the communications. The purple one is transmit on the Bluetooth module. So what I'm going to do is I'm going to plug that into the receive on the Arduino, and then the grey one is receive on the Bluetooth module. So I'll plug that into the transmit first, and then receive. And I'll just double check all of my wiring. VCC, ground, RX, purple is EX, goes to RX on the Arduino, and that should be good enough. Back in, and with a bit of luck, the LED on our Bluetooth module is flashing. That means it hasn't got a connection with anything. That's okay. Okay, so I've collected up an Android tablet, and I'm just going to remote into that. And there we have it. So there's the Android tablet. What I'm going to do is serial Bluetooth program here. Scan. And so X01 is that Bluetooth module. So what we should see now is that the red LED has stopped blinking. That means it's got a connection. For some reason, my Android disconnected its connection, so just start that up again. All right, so there we are. So connecting to unnamed, and now it's connected. But more importantly, what I can do is down here, I can type in some commands like A1 and send it. And with a bit of luck, the LED will come on. Go back here, I can type in B1, send it, and sure enough, the second one comes on. So I can type some more, C1, D0, D1, send. And now we have that pattern on. So the point there is that through the serial communications, you can just simply plug in something like a Bluetooth module, and I've just connected that to pin 0 and 1 on this Arduino Uno, and now I can send commands to it. So I could just very easily, again, if it was in the field or it's remote or it's off in a cupboard somewhere, just do something like that, plug in the Bluetooth module. Obviously, you need to have the wiring there for it, and then I can interact with it and testing wirelessly, in this case from my Android Android tablet. And obviously, if you have a Apple device, the same thing can happen. So sort of start to open up some really cool things. Now, I don't normally want to have something connected to pins 0 and 1 on an Arduino, because that's also the path that's used to upload code, and it's also the serial.print path as well. So if you have something else connected to it, that can interfere with it and cause some problems. So best not to do that sort of thing. And so that's where ones like the Mega come into their own. So we've still got the 0 and 1, which you can't really use on the Mega, but there's 3 more pairs of TX and RX down here. And so we can use those to actually communicate with multiple things at the same time as we still have the ability to upload code. And again, when we looked at the noughts and crosses program, I did, I think, point out that the wires were connected to serial 1 and 2 that go from one module to the other, and that's down here, and that was the wire that went from one side to the other. So we'll look at that a bit further, and we'll do some things with this, and we'll also do some interesting things with a GPS, and maybe some other things as well. Okay, so I think that's all I wanted to cover for this. So the next thing I'm going to do is I'm going to look at some slightly more sophisticated commands. So these commands are okay, sort of not terribly meaningful. I mean, we kind of know what they're doing, but not that intuitive. And so what I want to do is look at something, a way of managing some richer command sets, and we'll look at some attributes, serial monitor, sorry, the serial object, and some of the things they do for us, and perhaps why they're good or maybe not so good. And we'll look at some solutions to those challenges. Okay, so enough of that, let's move on. Okay, so we've covered turning off and on LEDs with simple commands. So let's move on to something a little bit more sophisticated. And in particular, I'm going to look at parsing. But before I do that, what I'll do is just show this simple program here. I've uploaded this program onto this Mega, and what I have here is a Bluetooth module connected to it. So simple character commands, or 2 character commands, which is really 1 character just setting different states, is fine and can work for lots of things and is perfectly valid for lots of scenarios, but sometimes you want something a little bit richer. As I said, I've loaded this program up. All it does is it transfers the data it gets from serial to serial 1, and that's where the Bluetooth device is connected. I just upload, sorry, I've already uploaded that, so I just open the monitor. Now we won't see much on the Arduino, so just get rid of that. And there's the banner, simple serial pass-through. And that message there, error, you can't see that in the program. That's because that's actually come from the Bluetooth device. So Bluetooth, there's lots of things you can do to set it up. And so simple 1 character commands really isn't going to cut it. So we need a sort of richer command set. And so I won't go into the history. You can look this up for the AT command set. It was to do with modems in the olden days. You used to use it to control the modem, to dial a number and all sorts of things, set parameters and so on. But they're always preceded by this AT command, and you have to be in a command mode for it to work. Otherwise, everything just passes through to the other end. So if I simply type in AT, that'll send that to the Bluetooth module. And you'll note I've got both new line and carriage return set. They won't work unless they get a proper line terminator. So when we say AT, it just says OK. Now we can give it some additional commands. AT plus help, and it gives us a list of commands that we can type in. So it's returned the version. This is running version 6.1 of the Bluetooth software. I can do things like AT state. Its state is, I don't know why it's error, but it's error. We can do things like AT plus name. So that'll tell us the name of the Bluetooth module. So if you do a Bluetooth scan, it will return that value. And we can also set it with a similar command. So I can say AT plus name. We need typing AT plus name red. And then if I recall that, there we go. So it says name is Fred. So clearly a richer command set is useful, and trying to process 1 character at a time would start to get pretty problematic because, you know, suppose we typed it in incorrectly. So he said sort of AT plus SL, and then we had to do backspace. So if we're processing those characters one at a time, it starts to become problematic to figure out what's going on. It could have meant that we're starting off sleep and gone down to the sleep path, and it's just very complicated. So it's usually better with these sorts of richer command sets to receive a whole line of input, which I'll typically refer to as a sentence, and then process the words or characters in the sentence. So we would maybe separate it into AT and then the plus and then the start. And we'd look at those words and then find out what word have we got. So have we got sleep, or have we got start, or have we got UID? That way, if the user is typing in corrections like backspace and stuff like that, or whatever, we don't have to worry about those sort of individual things. Plus, we don't have to keep track of working out, is the S going to be for start or for stop or for state? And then if it's S and a T, is it start or stop or state, and so on. And then what happens if they do a backspace? So now we're back to the beginning of the S's, any other S there. But hopefully you get the idea. So what I'm going to do is look at processing sentences, and we'll start off with some helper functions that the serial object gives us. And I personally don't like them. They're useful when you're working in the Arduino IDE, but beyond that, like if we're going to use putty, which I sort of showed earlier, there's certainly some problems with them, and we'll look at that and a solution. Okay, so let's get started with that. All right, so let's start off with a simple program, and we'll look at some of the serial methods. We can actually find those online. So this is the Arduino documentation for the serial object. Has a bit of information there about what's available on what platforms and what pins they use and things like that. So I'll be using the Mega a bit later on, because you can see it's got several serial objects as compared to the Uno, which only has one. So that's a bit of a problem if we wanted to connect up more than one device to it, such as the Bluetooth module. That's why Mega is better. But anyway, there's all these methods here that are really good, and they're largely suited for working with the Arduino IDE, in particular the serial monitor. And there's a few functions there that you can parse int, so you can remember we had the digits. They were actually characters. They're not numbers, they're characters. So you can use methods like parse int to take a series of those numeric characters and actually convert them to an integer or a floating point value. And we're already familiar with print and print line and begin. But there's these ones here: read bytes, readString until, and a few other things. So I won't go through all of these. We'll definitely be using begin. We'll look at readString until in this little section. But mostly what I'll use is available, so if available, and we've already looked at the read, so I'll be using read much from now on after we get past readString until. Okay, so let's get started. What I'm going to do is I'm going to borrow, I'll just recreate the blink no delay program just quickly. Okay, so that's a simpler version of the blink no delay. Obviously, I've set this heartbeat pin to 2, so that should correspond to this blue LED here. And we're getting the current time from millis, working out how long it's been since the last time we blinked, and I'm deliberately using a small number here so get it to sort of freak out a little bit as far as its blinking is concerned, and you'll see why that's the case in a minute. So if we've passed our time to do something, we remember the current time, so we know when to do it next time. And then this one line of code can actually blink the LED. So what we're doing is we're going to set the heartbeat pin, and we're going to set it based upon what its current setting is. So we're going to read the heartbeat pin. That'll give us what it currently is. So let's say it's on. And then this thing here, the exclamation mark, that's the negation operator. So it inverts it. So it'll convert true to false, yes to no. And in this case, just because of the way they've worked high and low, it'll convert high to low and low to high. So then we set that. So if it was currently on, this would end up turning it off. So let's upload that and see what happens. Go back to it. so Serial readString Explorer. Okay, looks like we have a problem. Spelling is important, or capitalization is important. Okay, and so we've uploaded it, and as you can see, that LED is freaking out with its blinking. All right, so let's have a look at the read string. And so what it says is it reads characters from the serial buffer into a string. So that's the first problem with it, in my opinion. String is a data type, an object that's provided in the Arduino IDE, and it uses dynamic memory allocation. And whilst that's okay if you know how it works and you use it wisely, it can cause problems with memory fragmentation and basically running out of memory and crashes and things like that. So this is another reason why I don't particularly personally like using these. But if you're only using just one of them and you don't use string for anything else or any other dynamic memory allocation, it tends to be fine. But it reads characters from the serial buffer into a string. The function terminates if it times out. See timeout. And this is the important thing. So this is what makes it sort of work well with the Arduino IDE. So we'll look at that. So let's turn on our serial object. As before, I prefer to use 115200, but open. So as I said before, you can use any number you like, provided it's one of these. I find 115200 to be a good balance of speed and readability. Okay, and so just put out a little bit of a banner. So we'll leave this blinking as is. That's working. It's doing what I wanted to do, which is to blink that LED periodically. And so we now start looking at the read string. So I'll start out with if there is something to read. So this method here basically says, is there something available for us to read? So back. And so what it does, it gets the number of bytes of characters available for reading from the serial port. So if there is something that's received, this will return the number of bytes that are currently available for reading. So that'll either be 0 or not 0. Now, because of the way C manages Boolean values, so true-false type values, 0 means false, and anything that's not 0 means true. So if this returns anything more than 0, or other than 0, then this will be true. So we could say this, that's clearer, but it's unnecessary, so I won't bother. That's a good tip for you to learn. So if serial is available, then we just simply want to read it. So we can go back over here and see the example here. String input equals serial.readString. That's it. So I'll copy and paste that. So when we've read it, we'll read the message, print it back to the serial monitor, and we'll enclose it in quotes so we can see exactly what we've got. Okay, so I'll upload that. Okay, and there's our message, Serial readString Explorer, so it's ready to go. Okay, so enter that, click send or hit enter, and there it is, hello world. And you can see it's got the new line in there as well. The quote is on the next line. I can turn that off. And you can see now it's missing the quote. So for the serial monitor, that's probably a little bit easier to use. But the way this works is it uses the timeout, which is what it says back. the function terminates if it times out, set timeout. Don't bother to look at that. You can look at that by yourself. So what that means is you'll notice that there's a little bit of a delay from when we hit enter, or I'll click send this time so it's even more clear, to when that message appears. Even though there is no delay in here, we simply read it and then we print it. There's no delay here, but clearly when we click send, there'll be that delay, and you'll also notice the LED stops blinking. That was a brief period of time there, it stopped blinking, about a half a second, I think. Try it again. It might even be a full second and a half. Anyway, there's some delay there, and you can see the LED stops blinking. That means all processing has suspended on the Arduino while it's trying to read the input. Now, there is another variant that we can use. Go back. And that's readString until. Now, readString until reads until it sees the terminator. So we can use any character that we like. Semicolon, for example, like we put at the end of a line of C programming. So I'll use that. We could also put a new line or whatever. That's usually what we use. There's no example here, so it doesn't really show you how to use it. So we'll have a quick look at it over here. That one, this one. So I'll comment that out. I'll do that readString until. Now this also has the timeout. Reads characters from the serial buffer into a string. The function terminates the timeout. It doesn't say, but should say, until the terminator is observed. So this will also stop reading when it sees the terminator. So I'll do here. I'll upload this. readString until semicolon. So this will be the same. You'll see the delay, and then it'll return the string. I said this, and we should return it immediately. Oh, no, it still has the delay. A little bit surprised about that. But what we should see is that these will be separate. Okay, so that's a little bit surprising. Oh, that's why. The parameter is a character, not a string. Basically, our terminator was a random value because it was the address in memory of where that string was. So this should be a little better. Okay, so I'll start with that one again. So we should still see the delay. This one with the semicolon, which I would expect to return immediately, and it did, and it removed the semicolon. Now if I do this one, then we get two lines returned. I'll change it a little bit so we can, I'll just run it again. Okay, so we get two. Notice we've got an extra space there. That's because of that space. If I didn't want that, I'd have to sort of move the punctuation myself, and we can see it comes out like that. Now notice in that case it was still perfectly fine. If I had line 3 without the semicolon, then I still get the delay because it's not finding the semicolon. It has to wait for the timeout to occur. Okay, so that's nice. That's good. Now, as I said before, we might not always want to use the Arduino IDE on our system. Okay, so I don't know why it was out of focus there, but it wasn't terribly important because you could still see the LED was blinking or not blinking, even though it was blurry. I think it was actually something to do with the blinking of the LED that was causing the camera to get confused. But anyway, as I was saying, Oh yeah, sometimes you might have a project deployed that you don't necessarily want to have to install Arduino IDE just to use the serial monitor. And you might just want to download something simple like Putty. In fact, Putty is just a single executable on disk. You can just download it, copy it, and run it, and you get all of this in that one executable. So it's no installation process. You just could have it on a USB drive and plug it in, and it will be available to you. So I'll open up the COM20 at the correct speed. There's our banner. And I don't have any echo turned on, so you won't be able to see what I'm typing. And that's another issue with the read string, is that, again, all processing stops. You're at the mercy of what's going on inside there. And in the Arduino IDE, they don't need echo because you could just print out the message received if you wanted to. And so you don't have that ability. So I could type things in. So I could type in hello, semicolon, there, semicolon. And you can see we get the 2 lines of input one at a time. Now, if I was a bit slower typer, if I was going to type HE, then find the L, now where's the O? Here it is. You can see now we've got 3 lines of input, so that's a bit of a problem. The other thing it doesn't handle very well, because again, the serial monitor manages the editing of the sentence that you're typing in its little inbox. It doesn't need to have support for hitting the backspace key or anything like that. So if I typed in HELLO backspace, well, for a start, I'm getting confused where I am, FGH, then you can sort of see we've got some sort of strange results here. We've sort of got hello, and outside of the quotes, we've got LO, and it's just sort of really weird. And then there's a bit more down the bottom here. So using this is a bit of a problem in that, you know, if we don't type our commands in fast enough, like hello, then we won't get it all on one sentence. And so it's a little bit trickier to sort of start figuring out what's going on when we're trying to process these commands. So hello there. Right, and now you can see I hit enter this time. So the closing quote is at the beginning of the line because the enter generated a carriage return. So if you were only ever going to use the Arduino IDE, this is fine. If you're only ever going to use the one string, then this is fine as well. But if you're starting to do a bit more complicated things like string concatenation and creating your own string variables and using other packages that use strings or dynamic memory allocation, you could eventually start getting some problems with, as I mentioned before, I won't go into the details of it. That can be the subject of another video if you're interested. But memory fragmentation that could lead to, you know, random system behavior and crashes and all sorts of undesirable behavior. Okay, so I think I'm going to leave it there because this video is already getting very long, much longer than I thought it was going to be. And I didn't even cover some topics that I wanted to, such as software serial, which is completely out of the video now. So we'll leave it there, and next time we'll look at how to deal with some of the problems that I've addressed with or raised with the get string or read string, and create some reusable objects that we can use in more complicated programs with more sophisticated ways of processing the data. And as I said in the beginning, we'll look at the game. So if you like this video, leave a comment. Don't forget to like it and subscribe to the channel and turn on notifications so you see when I post new content. And hopefully see you next time. Thanks for watching.